my numerator over to here, so I have y to the 9/2, z to the 3/8. Everybody okay with me so far?
Yeah.
All right. Now, in this problem, there's no x values in the numerator, so I'm going to make the decision to go ahead and rationalize my x values first. That way it's just going to look a little bit cleaner when I go through. How many more 8s do I need to create the whole in this case? 7 of them. Good. So I'm going to multiply top and bottom by the 7/8, x to the 7/8. And that'll give me a new numerator. I'm just going to put them in order. X to the 7/8, y to the 9/2, z to the 3/8, all over. Now my x value, I've created another whole so it becomes x to the 4th. And then the last two are, we have a z cubed and z to the 1/2. We okay so far? There was no y. That's another x. Okay, those were just x's. All right. Now, excuse me. Make sure everything's there. Yep, I'm good. So here, the last little bit then is to notice that you have z to the 1/2 and z to the 3/8. Is the 1/2 bigger than the 3/8? Yes. Yes. So before I try to rationalize any of this, because it's just going to get really messy, I'm going to simplify it first. Okay? Always try to simplify before you rationalize when you have fractional exponents. It'll help clean it up some. Okay? Especially when the denominator is larger than the numerator. So this one's pretty easy. 1/2 and 3/8. That would, when I subtract those two out, I'm going to get what for my denominator? 1/8. Good. So in my head, I'm just going to cross this off because it goes, and I'm just going to erase this and turn this into a 1/8. Okay? Are you all right with that? From here, I rationalize out. I just have to multiply top and bottom now by 7/8. And I guess you could do this earlier. Sometimes it alleviates duplicates. But now you have another whole in the denominator, and your numerator is the 7/8. So it's x 7/8, y 9/2, z 7/8. And we have x to the 4th, z to the 4th. And that's what I got for a solution on it. Pretty sure that's what they had as well. So. A couple of the ones I noticed yesterday when I put on the calendar, we found right off the bat I forgot to cube one of the denominators. That's why you saw a note on the calendar that I think what was it 16. I think was I forgot this. It should have been over. It should have been over 16 instead of over nothing. But that was just someone. I think there was. What was the other one we found? There was another one we found too, wasn't there? It was a simple one where I actually wrote a 4 instead of a 3. I think. We'll go through some of these, but we'll figure it out. What do you got, Sarah? I make sure that they're not this god awful. This one's pretty gross. There's a couple on the back that are pretty gross. I try to keep them pretty straightforward. Let me look at my notes. Because I did all of these yesterday, and I know some of them are shorter than others. Yeah. When I'm looking at the ones here, guys, ladies and gentlemen, let's see. 12 was pretty gross. 16 wasn't bad. 18 was pretty gross. 18 took me almost 3/4 of a page. Then again, I write large, so. 20 was pretty quick. And then the odds, I think the odds were a lot easier. The odds were actually quite easier. The only one that was pretty bad as far as the odds was 11.
it's just a lot of work. It wasn't tough, but it took about 6 or 7 steps to get through all of it. But as far as the even stuff is concerned, I posted all the evens are on there, and I also just posted this. I think I posted that already this morning. The odds on there as well. So those are all up for us. As far as the even ones are concerned, what do you want to look at, Sarah? Okay, I can answer those, maybe.
So like score. Should be isolated or should those?
Good question. This is a very good question. I actually had some people working with 4 yesterday, and what I find to happen a lot of times when students work with ones like this, they try to do too much at first. So when you see something like number 4 is a good one. I like 4. It's pretty straightforward. It's got a mixture of a bunch of all the different options you can do. You've got simplifying, you've got your power to powers, you've got negative exponents. You have a really good mixture of all of it. Whenever I see ones like this, does everybody agree that I can't do anything until I take care of the power to powers in the denominator?
Yeah.
Okay. So what I do whenever I see something like this is I split it into smaller chunks. I'm going to take care of the power to power for both parts of the denominator before I try to combine anything. Okay? So I just rewrite my numerator, 2x, y to the 4th, and then I have power to power of all this. I have 4 times x to the negative 8th times y to the 4th. Remember, when it's exponents, you multiply, and then 2 squared is just 4. And then I do that again with the next piece, times 4, x to the 8th, and then y to the negative 6th. You okay there? Now, I always have been a strong advocate of taking care of numbers first. What's 4 times 4? 2 over 16 simplifies to what? 1/8. Good. So numbers are done. I know it's something over 8. Okay. Now, in the denominator, you have an x to the negative 8 and x to the 8. What happens? Well, one of them would move up, but then what would happen? They would cancel, wouldn't they? Because since you're same base, and you're multiplying, you just add the exponent. So right off the bat, you can just go, okay, I know that's going to happen. Or you can rewrite and then do it later. It's fine. If you recognize it, go for it. It's fine. Okay. Now, also, I have y to the 4th in the numerator, y to the 4th in the denominator. Those are gone. What's left? Well, we already took care of our numbers. We already know that's all gone. What's left? I have an x. And what happens at y to the negative 6th? Don't make it hard on yourself, Beanie. Go slower. Take your time. Okay? Seriously. Don't overthink it. It is so much easier than you guys give yourselves credit for. All right? Just break it into smaller pieces, and it makes it so much easier. Okay? Break things into smaller chunks and work it off of there. All right? Does that help on that one? All right. What else want to look at? We have plenty of time to do problemos. 18. This one's so ugly. All right. Excuse me. So, first thing I'm going to do is I'm going to rewrite my numerator after distributing the 1/3 for the exponent, and then I'll just rewrite, and then in the denominator, I'm just going to put everything, just rewrite it right off the bat, so we have a new problem then. So we'll have, what would that be? A to the 1/6, C to the negative 1/9, all over A to the negative 1, B to the negative 3/2, C to the 7/4, A to the 4/3, B to the negative 2, C to the 1/2. Okay. From here, I would start worrying about, you can do a couple different things. You can move your A values up and down and the B's up and down and all that. But since you're sitting there in the denominator itself, why not combine them? You're multiplying. Same bases, different exponents. What's negative 1 plus 4/3? 1/3. Okay? So I'm going to rewrite, I'm going to get A to the 1/3. I start with that. That part's taken care of. Negative 3/2 plus negative 2 would be what? Negative 7/2? So I'll rewrite it as negative 7/2. Those two guys are done. 7/4 and 1/2 would be, what are they, 2/4 would be 9/4. And then the numerator then is still a to the 6th and c to the negative 1/9. All right. So far, so good-ish. All we're doing is just adding fractions here. All right. Now, let's see. No, not. Thanks. And now let's go. Simplifying the A's. When I simplify the A's, 1/6, 1/3, who wins? 1/3. What is 1/3 subtract 1/6? 1/6. Okay, everybody okay with that?
Yeah.
All right. So I have a 1/6 now in the denominator for A. Negative 7/2. Well, that's simple. Just send it up. Now I have the 1/9, the negative 1/9, and the 9/4 to worry about. This is the one that makes it look kind of crummy. Yesterday, you guys saw that sometimes I would take the fractional exponents and split them into kind of like a mixed number-ish thing.
Yes.
Well, how many times does 4 go into 9? Twice. How many are left over? 1. So underneath this side here, I'm going to rewrite this as c squared and c to the 1/4. You okay with that? Which means when I move that 1/9 down, I have to add these two guys together. What stinks is that it's not that bad. I mean, what's the common denominator of 4 and 9? 36. So at least you don't have to worry about anything crazy, and the numerators are 1. So the multiplying portion to get the common denominator isn't going to be bad. So we have 9/36, 4/36. So it's 9 and 4 is 13/36, I believe. So now we have c squared and c to the 13/36. All right, and that's just adding that 1/4, 1/9. Okay. How many more 36 do I need to get to the whole? A lot, you're right. How about 23 of them? So if I use 23 of them, then my final answer would be, I forgot what A was up there. B, 7/2, C, 23/36. Oh, and 8 of the 6th. I gotta make a hole here. How many more 6 do I need? 5/6. That's pretty easy. I'll put this up here. 8 to the 5/6. So now my denominator is A to the first power, and then C to the 4th. Oh, sorry, third. Because this was 2 and then plus 1. I think that's right. Because the denominator, how the denominator was C, with the C to the 4th, C to the 9th. I got the 20 or 13/36. I had to rationalize that to create the whole. Okay. All right. Yeah, I don't know where I got, because there's nothing else for you to do. You can't simplify anything.
have B values. Oh, I'm somehow actually wrote an extra B value whenever. Oh, you know what? I did. On the answer guide on that one, I don't know if you guys noticed, I accidentally wrote this as a B when I did that. So the answer, if you look at the answer on the calendar, it's right if that's a B. Oops. Yeah. So that kind of stuff can happen. Let's say you did that on a test or a quiz, and you did all of it right, but you wrote the wrong letter. Yes, you got a big fat zero in your like it. Anyway, what do you got? Oh, okay. What else do you want to do? Más problemos. You know, I have been known to split stuff that just, you do a little bit of work, then everything, all of a sudden the answer is like 3. Where everything simplifies out and you wind up with just a whole number or something. But if you do it right, it goes real fast. All right. So in this one here, first thing I would do is before I worry about my exponent, that 4th degree, I would look at the stuff on the inside. What's 2 over 2? So those go away. What's x to the 0? 1. So that we don't have to worry about this. So now my new fraction, when I move the other stuff up, will be x to the 3rd, y to the 8th, over 2x, y, and this is all still to the 4th. Okay? One more thing, I would simplify the x to the 3rd and x to the 8th, or y to the 8th, and I get x squared, y to the 7th. You okay with that? And now I just do my power to powers. Okay. From here you do your power to powers. Oh, this is the one that I forgot the 2 in the denominator because when I was writing it out. Okay. So when you do your power to powers, you're going to get x to the 8th, y to the 28th. 2 squared then becomes 16. On the answer guide, when I was crossing stuff out, my pen accidentally grabbed the second 2, and that's why it looked like I forgot the 2. Yeah. So simple. What did you do? I thought you did. Yes, sir. 20. A lot easier than it looks like it should be. See? I knew I did it right because I just checked my answer. All right, 20. So in 20, first thing I'll do is take care of that numerator with the power to power stuff. But what's a to the 0? 1. And what's c to the 0 in the denominator? So I don't worry about either one of these. I just kind of do that. So now I get my new numerator, b to the 4th, c to the -5 halves. Then I'll just rewrite the bottom for right now. A to the 5/4 negative ac squared. Okay? -5/4 times 2 is -5 halves.
All right. From here, excuse me. From here, what's negative 5/4 plus 1? Negative 1/4. All right. So all I'm doing is I'm combining these two right away, and I'm going to get a to the negative 1/4. Okay. I don't have to worry about rationalizing that negative 1/4, do I? I have to bring it up.
Right.
So I'll bring that up. A to the 1/4. Bless you. Wait. What's b to the 4th over b? B to the 3rd. So I just have a b cubed here. Denominator now has the c to the 5 halves and c squared. 5 halves is how much? 2 and 1/2, okay. So you can split it, or in this one is, since this one isn't so bad, how many more halves do I need to make a whole? One, right? So I have to multiply top and bottom by c to the half. Now the only disadvantage of doing it this way is that you have to remember that what's 5 halves plus 1/2? And 6 halves is 3. Okay, that's the only tricky part about doing that. Whereas when you did it the other way, by splitting it apart, your partials just always made 1. In this case, I'm just making it a little bit more. I'm just showing you guys you can do it different ways. Sometimes it's cleaner. It's easier when you have halvesies. That's just me. So your final answer then would be a to the 4th, b cubed, c to the half, over c to the 5th.
So if you had like, say you had like a C to the
C to the 3rd?
you don't have one, that's what
No, because once you get a whole number in the denominator and your fractional amount of that same variable is less than 1 in the numerator, there's no more warping. Otherwise, you'd wind up just rationalizing, re-rationalizing, and go back and forth. Okay, and you just wind up with fractionals of length. Yes,
Sorry. For number 1,
yeah.
you would distribute the first one, right? And then does the exponent go to the bottom end?
Yes. Yep. Before I'd even do that, I would simplify out the 2 over 16 and then just distribute it that way. And it works out really, really fast. Yeah, 1 is actually really easy. Get large exponents, but the numbers are quick. What else do you want to look at? What other one looks awful?
11.
Not doing 11. That one is terrible. 11 is terrible. Don't worry about 11. 11 is it's. Ugh. I already did 14.
No.
Oh, it's like 14. Yeah. 11 and 14 are very similar. The what? Well, there'll be stuff like that on the quiz, but they're not going to be. No, they won't be as. I mean, there's a couple on here that are a little bit. I mean, it's tough to generate these problems and make them difficult without going maniacal. All right, you know what I mean? Without going horrible. Like, I'm going to get you. Or, good luck, you know. What else we got?
Where?
Not off the top of my head. She's short enough to fit on the ride.
That's a rock.
What else we got? Oh wait, no, 12 is okay. Alright, let's get a 12. Did I do 12? Did I do 12? Yeah, you did. I just say, like, wait, I just don't remember. So 12 looks like it's going to be terrible.
That is not That's our 11.
Yeah.
Wait, sorry, I don't know. Our 11 is here. What is so far?
Oh, this.
Yeah, that's our 12.
Yeah.
Oh, okay. I don't know. Wow. Did I mix these up?
Yep.
Nice job.
Yep, you did.
She just does that sometimes.
Wow. Alright. Anyway, so this is number 11, which could be number 12, which could be something else, but I don't know. Apparently. So obviously in this case here, first thing I'm going to wind up doing is take care of the exponents in the numerator and just rewrite. So when I do that, I'll have n 1/2 m to the 1/3 p to the -7/8. All right. Power to power, I just multiply all that together. In the denominator, as I write them down, you've got 3 variables twice. I'm going to combine my like terms. Okay, take care of all of your combined like term stuff right off the bat. M to the 0 is just 1. I have n to the 4/3 and n to n squared. Are you okay by saying that that's going to be n cubed and then n to the 3rd?
Yeah.
Okay.
I like that.
Let's see.
Or no, it's not. I'm sorry.
That's okay. I have m. I'm just keeping them above one another here, so I have m to the 1/2 then. P, I have p squared. This is the case where I like to split them apart a little bit again. Before I move anything around, before I try to rationalize anything, the only thing that I can kind of simplify is notice that I can bring the 1/3 of the n up to the 1/2. I can move that up there because 1/2 is larger than 1/3. So when I do that, 1/2 in terms of 1/3 would be 1/6. So it'd be 3/6 subtract 2/6, and I'm going to get 1/6. You okay with that?
Yes.
So my n value in the numerator becomes n to the 1/6.
All right. Same with them.
Yes. Now, when you do that with m, where does it goes to the bottom? Then. Good. So now you have m to the 1/6. It's convenient that the math is the same.
Yeah.
So the m's are done. The p squared I know is still going to be here, and I have to move that 7/8 to the 3/4. Once again, that common denominator is really easy. 7/8 and 3/4 would be 7/8 plus 6/8. So it's what, 13/8? So now it's a matter of rationalizing. How many more 6 do you need for the m? 5 of them. That's close. You're halfway there. Ish. So you need 5 more of the 6. Now with the p-value, this is greater than 1, isn't it? So do I need to split it, or can you guys kind of figure out how many more 8ths you need to get to the next whole number? How many more do you need? 3. So we'll multiply top and bottom by m to the 5/6, p to the 3/8. And that gives me N 1/6, M 5/6, P, what's that? I'm trying to, what I'm doing here is I'm going to the next whole number. This is, since this, the next whole number would be 16/8. Did you split it apart? Because that would have been 8/8 and 5/8, so it still had to go 3/8. Okay. So then you have 3/8. Denominator, N cubed, M went to a whole number. What does the p-value become here now? 4. Good. And that's the only tricky thing when you're working with the exponents. When your fractional exponents in the denominator are greater than 1, when you go to the next whole number, you got to be careful of what is that next whole number. Okay? I like that one. That's about as complex as I like to go. All right. It's like a beef stew with some French bread.
M to the first.
Which one did you say? Is it 13? Two 16. Please. There's no please. There's no pleases. No thank yous.
Oh, no, please.
Jeez.
I'm very pleased to have
Let's see. Is my 16 your 16?
Yes, it actually is.
Yep, it is. I don't know how that happened. 16 is another decent one. What's your denominator?
1.
Okay, so you're halfway done. After that, guys, come on. After you start going through that, we know that this denominator just becomes 1. We know also that the z value here, negative 5/3, has to move down. But before I do that, when I add negative 5/3 to 1, what do you get? Negative 2/3. So I'm just going to kind of simplify the z values as I go. So it's z to the 2/3 here. Numerator, x to the 5/3 plus x becomes x to the 8/3.
Yeah.
Y to the 3 halves and y squared would be 7 halves. And then what do you have to multiply the bottom by to bring it up? 1/3. That's another good one.
Really?
Is this what it's going to be like in the future? Or
Could be.
what degree will it be?
Like fractional.
Well, between like this and
Yeah, I try. Like I said, I'm trying not to get you. I mean, what was the one that we wound up with? Hey guys. Was there one that we wanted to really off? The one denominator we had 36, but remember, that one had a 1/4, 1/9. And I'm not going to make it like 3/4, 7/9 and have to do 36 out of that and make it go. I try to keep it as clean as possible. These fractions, the ones that we've done today, have all been pretty decent except for that finishing up to what is that, 14?
Yeah.
And then I think there's one other one that's kind of awful, but
18.
they're really straightforward. I think the odd ones wound up being, and I apologize, I don't know how we had two different versions of this when I printed it all out at the same time. They're all pretty straightforward. The odd ones that I put online last night, or this morning I should say, the only thing I just realized on the odds was on number 1. My answer on number 1, guys, I wrote this. I forgot to cube the 8. So 8 cubed, I think is what, 512? So there should be a 512 in front of that. So as I was going through the problem, I was doing these. It actually worked out rather well. Connor had basketball practice, so I brought my math homework, and I did math homework while he had basketball practice. Yeah, that's what you do. I'm just ready to do that. Did I just do 19?
Bro, we did.
Bro?
Yeah, we did 18. I have it right here. 19. We get 21.
I think this is the right one. So on number 19, first thing I did was I distributed the 1/4 power to the denominator. So I have x to the 1/2, z to the negative 1/4. And then at that point, I know that things have to move up and down. So I'll just rewrite real quick, y to negative 1. Just do this. So I know that y to the first is going to move down. And then I have y to the 1/2 up top. So it's y to the first here, y to the 1/2 up top. There's no other y values, but if I play war here, what's going to happen? The bottom's going to win, then it's going to be fractional, which means I have to multiply it again to go back and forth. Whenever you have whole number in the denominator, fractional in the top, you just wind up being what's called an infinite loop. You just be going back and forth over and over again by rationalizing and going, rationalizing. It's not, you're done. You can't do anything with it. Okay? After the y values, then we have z's. So I have 3/4 and negative 2/3. So if I combine those real quick, obviously, I'm sorry, I'm going to bring a 4th up. So I have z to the 4/4, so z to the first, and then I have z to the negative 2/3. What's z, or the first, times z to the negative 2/3? 1/3, right? So that one's, z's are taken care of in the numerator. Then what's left? We did all the z's. We have the x to the 1/2 and x to the negative 3/2. So that x to the negative 3/2, moves down. What's 3/2 plus 1/2? 4/2, which is 2. Yes. That's right. I know I skipped. I think I skipped a couple steps because I'm running short.
When did that wasn't there like already there? And then you moved this z to the 2/3 back down. And then
I moved that 1/4 up to the 3/4, so it gave me a whole. A whole minus the 2/3 was the 1/3.
Oh, okay.
Okay, that's where I got
So you
that.
didn't actually
What?
remember. The fish up there next to the clock.
It was part of the Christmas door decorations that I did. You know what's that? It's really bad. There's a restaurant in Chicago that did going up their whole stairwell is a whole bunch of Billy Basses that they're coordinated to sing and dance to the lights and music, and it's all programmed to do all this stuff to the certain songs.
Yeah.
Yeah, I'm gonna take you guys to Chicago to go to a restaurant to go see that. Yeah, can I show you the video of that? We can count them. 1 little, 2 little, 3 little fishies, 4 little, 5 little, 6 little fishies. This is getting really squishy. I'm gonna stop singing now.
Squishy is the name of Doris Jellyfish.
And this is why. Go back to your happy place.
I didn't understand about the, like, I understand what the big